Hello everybody. I wanted to go over the average rate of change. As you can see on the board here, this is the formula for an average rate of change, f of b minus f of a all over b minus a. Now, this is very similar, in fact it's exactly the same thing as finding the slope of a line. In fact, you can think of this as y2 minus y1 over x2 minus x1. It's a very similar concept here. The difference is we're dealing with functions and we're trying to find, a lot of times you'll have word problems that try to find the average rate of particular functions that you're given based on a time interval or any type of interval, but some sort of interval. Now typically what I do here is I let b stand for bigger number. This is how I remember it. It's just by habit I do it this way. So b is equal to the bigger number. Let's take a look at an example here so that we can further understand this. Alright, so we have a function here, f of t is equal to 2t squared minus t. And you see here we have a t equals 3 and a t equals 6. If we recall, the rate of change is equal to f of b minus f of a over b minus a. And what I like to do is have b equal to the bigger number. So we're going to let b equal 6. So in this example here, we're going to say that b is equal to 6 and a is equal to 3. So the question becomes, okay, well, what is f of b then? Well, f of b, which is 6, f of 6 is equal to, I just plug 6 into my function here, 2 times 6 squared minus 6. And we get, let's see, we get 36 times 2, which is 72, and then we subtract 6, so that looks like that's going to be 66. And let's also figure out what f of a is, which is f of 3. Okay. And so f of 3, we're just going to plug in 3 into our function up here. So 2 times 3 squared minus 6. I want to make a correction here. I was writing 2 times 3 squared minus 6. However, it should have been 2 times 3 squared minus 3. I was supposed to plug in 3 for the t's in the function, but I made the mistake there and did not do so. It makes the final answer become 17 when we get to that point. And doing this math, we get that this is equal to 9 times 2 is 18. 18 minus 6, that's 12. So if we're to use this formula here, let's just plug in the values that it's supposed to equal. Well, we're saying that f of b is equal to f of 6, which is 66. So I'm going to put a 66 here instead. F of a, which is equal to 12, I'm going to put that here instead. And then we have b minus a, which is 6 minus 3. So I've worked out what everything equals here, and I've just plugged them into the formula for the rate of change. Now, 66 minus 12, this is equal to 54. And then on the bottom here, we have 6 minus 3, which is 3. And we can simplify this farther by dividing 54 by 3, and we get 18. This was the part where I was saying the answer would be 17. So the correct answer to this should be 17. And if you actually fix all the math, you'll find out that that's what it would be. So this is how we would find the average rate of change in this example. Let's take a look at another one. All right, here's an example, another example of the rate of change. In this case, the difference is is that one of our t's has a plus h in it. You do this the exact same way. Remember, it's f of b minus f of a over b minus a. So to start with, I can say that this is f of b minus f of a all over b minus a. So we got f of 3 plus h minus f of 3 over 3 plus h minus 3. Now, this problem's a little bit lengthy, so let's go on. What we need to do is plug in what we see here for the t, okay, in both cases. So now what we have is 5 times 3 plus h squared minus 5 times 3 squared all over, and we can go ahead and see here that these 3's are going to cancel to 0. They're going to subtract out and become 0. So all I have left down here is an h. So now let's continue on here, and we're going to FOIL this part. We're going to use FOIL expansion to multiply these two binomials here. Remember, this is not going to be 9 plus h squared. Don't do that. That is incorrect. This is like saying 3 plus h times 3 plus h. That's what this 3 plus h squared is actually doing here. So if we FOIL that out, we'll get 5, and I'm just going to do it. You can FOIL it out yourself. Here we would get 9. And then we would have a plus 3h and plus another 3h, so that's plus 6h plus h squared. Minus, now this can become 45 here, because this is 9 times 5. All over h. So let's continue this here. So if I multiply this part out, distributing this, I'm going to get 45. And then here I'm going to get plus 30h. And then here I'm going to get plus 5h squared. And that's still minus 45 divided by h. All right? Now what we can see here is this 45 minus this 45, that's going to subtract to 0. So now we're left with 30h plus 5h squared divided by h. Okay, let's move that up. So now, at the top, we see that we can factor out an h here. Let's factor that out. And of course, we're still all over h. Now, the reason why I factored this this h out, is because now we see these divide to 1, so we can cross them out. So finally, we're just left with the answer, which is 30 plus 5h. So this is the answer for the rate of change based on the interval that was given, which was 3 and 3 plus h. Let's take a look at some word problems now that involve rate of change. Okay, here's a problem from a textbook, and it gives a table here, and the question says, the word problem itself says, a man is running around a track, and now this track, I shorthanded this, so the track is 200 meters for each lap. And an observer is using a stopwatch to time this man going around each lap. So after he's gone over one lap of 200 meters, it took 32 seconds. Then he went another lap, which gives him a total now of 400 meters, and he's gone 68 seconds, and so on down this table. The question is, what is the man's average speed between 68 seconds and 152 seconds? So to do this, we just use the average rate of change formula. We're going to take 152, the bigger number, minus 68, that's what goes down here. And then what goes up here is the distance associated with those times. So 152 is 800, and 68 is 400. So all we have to do now is just figure out what this value is. So this becomes 400 over 84. And when you do this division, you get around 4.76. So the average speed here was 4.76 meters per second. And that's how you solve some application type problems using the rate of change. Now let's look at something from a graphical standpoint. Okay, suppose we have this graph and we're asked to find an average rate of change from a specific interval here. In this example, it's asking from 1 to 5. Okay, so again, using the rate of change setup, we're going to take 5 minus 1, remember the bigger one, b minus a. Remember, this is the formula here. Okay, I just want to write that down. All right, so this is our b and our a. Now, what is our f of b? Well, we got to look at the y value for at that particular x value. In this case, we're using x's and y's. Okay, I didn't label my axes, but let's assume that. So if my x is 5, then my y value here is 30. So 30 goes here. And then if x is 1, then my y value is 10. So it's 30 minus 10 over 5 minus 1. And if we do the math here, we get 20 over 4. And that's equal to 5. Now, I just want to make this clear what we're actually doing when we're finding the average rate of change. Visually, you can think of it like just finding a slope. So even though we're finding the average rate here, what we've actually done was y2 minus y1 over x2 minus x1. So really, the average rate of change is technically just the slope of this dotted line that I'm drawing through here. And that's why it's called an average, because it's not the rate of change at any particular point. This comes up in calculus where you learn how to do stuff like that. But here in algebra, we're just getting introduced. Essentially, we've found this slope between these 2 points, and we've established that that's the average. Now take a look. If we were to change this to f of 3, from 3 to 1 instead, notice the slope of this line differs. Okay? So what that means is the average between those 2 points are going to be different. Okay, so that was several examples here on how to find the rate of change.